Okay, so now we need to talk about the three basic rules of or properties of logarithms. Okay. One rule or property is if you have something like, oh, that's too big. You have something like log, let's do log base 10. So log of xy, okay, you can rewrite that as, since they're being, x and y are being multiplied, you can rewrite that as log x plus log y. It works, okay? Or if you see the sum of two logs, you can write it as a single log, right? Like that. All right. Another rule is very similar. If you have log of x divided by y, well, let's see. If multiplication yielded addition, then division would probably yield subtraction. Okay, cool. What about log of x to the a power? Okay, so how could we simplify that? Well, if everything being plugged into the log is all being raised that same power, then you can pull that power out, put it out front. Okay. And those are the three properties of logs, okay, that we want to work with in this section. All right, so using those, let's see if we can figure these guys out here. So on part A, we've got log base 7 of 2 plus log base 7 of 5. So I see that we are adding a couple of logs. That looks a lot like this. So when they say, hey, let's make it all a single log. So if you're adding logs, how do you make it a single log? Well, you multiply those guys together. So you're going to go, so multiply the arguments of the logs together. 2 times 5 is 10. Okay. What about the second one? Well, it's similar, except now I see the subtraction of logarithms. So it looks like we're going to be doing the subtraction rule here. All righty, and it says that if you have one log minus another log, that you just do the first argument divided by the second argument. So the first argument is 8, and the second argument must be 5. So that's the only thing that makes sense. Now, if I combine these two together, yeah, I get the 8/5. That makes sense. And you can always just plug that in on the main screen of your calculator and then plug that in. You should get the same answer. You really ought to be doing that every time. Same thing here. Plug that in, you should get the same answer. Now this last one, we've got a number out front, and and so that's cool. And one thing that tips us off on this one that we're doing the exponent rule is that neither side of the equation has a pair of logs. In order to use one of the plus rule and the minus rule, you gotta have a pair of logs on one of the sides. Okay, so this one's a little trickier. Well, 1 over 25, that can be written as 1 over 5 squared, which is 5 to the negative 2. So in order to pull a negative 2 out of this guy, the 1/25th has to be written as 5 to the negative 2. Then you can yank that negative 2 out, put him right there, and you'll just be left with the 5. And that would be the answer. That one's a little tricky. Negative exponent, all that. And then you check your work on your calculator and everything is hunky-dory. Okay, now, new topic. So it says use the properties of logs to expand this log. So we're just going to use those three properties as much as we can to break this guy up. It's kind of like saying, hey, here's a carburetor, take it apart, or whatever. So I I see an exponent, so I know I'm going to do the exponent rule. I see a division, so I know I'm going to use the division subtraction rule. Don't see any addition or multiplication. So this guy we're not going to need on this particular problem. The question is, which of these two rules do I do first? Well, not everything in here is being raised to the sixth power. So if I pull the 6 out right away, that's not really going to make sense. But everything in here is being is part of a division. So I will use the division subtraction rule. So that'll be log of x to the sixth minus log y. And the base is 10 because I don't explicitly state it. Now I can pull the 6 out of this guy because in this first log, everything in the log is being raised to the sixth power, namely the x. So I can pull that 6 out using the third rule, the exponent rule. And that's as far as I can take it. Okay. Let's see if we can find something just a wee bit trickier. Well, they don't get too much trickier on this topic, but they will in just a few moments. Okay, so this one, I don't see any division or subtraction, or subtraction between logs. So that rule, not going to need. But I do see an exponent. So I'll need that exponent rule. And I also see that z is being multiplied by x squared. So I'm going to need that rule. So which rule comes first? Well, not everything in here is being raised to the 2 power. So I'm not going to do the power rule first. I'll do the exponent rule, or the multiplication rule, excuse me. So that'll be log z plus log x squared. Now, that's a 2. Now I can pull that 2 out. Oh, wait, I need the one. Let's see. And it's all done. Okay, so now we kind of step things up just a little. Same rule or same instructions. Just break it up all you can. Once again, there's no. I don't see any division inside that log, so I'm not going to need the middle rule on this one. And not everything inside the log is being raised to the 7th or the 5th power, so I can't just pull the exponents out. But everything in there is part of a multiplication, and so I'll do the multiplication rule. So I get log z, that's just a z, plus log x to the 7th, plus log y to the 5th. And now I can pull those exponents out. And I get log z plus 7 log x plus 5 log y. And that's it. Okay. And it wouldn't be a day with logarithms unless you saw a problem like this one. Okay, so this is as tough as they get. These are the more fun ones. So all of this is in the argument of the log. All of that's being plugged into log base 10. So how do we handle that? Well, first off, the cube root, third root, that's the same thing as the 1/3 power. That's the same thing as the 1/3 power. Now in this case, everything is being raised to that power. So let's start off by using the exponent rule and bringing the exponent out in front. Am I writing this down right? Yeah. 8 and 5. Okay. So I got all that. Now, is everything being raised to the 8 or the 5th power? No. I see a multiplication right in between those two little piggies, but it's not one big multiplication expression in there, but it is one big division. So I'll do the division rule, this guy here. And so that'll be 1/3 log the top minus log of the bottom. That's 2, 8th x to the 5th. Now, to help with readability, I'm going to put brackets around that. Remind me that all of that is inside that second log. Now, I made a little mistake there, okay, on purpose. The 1/3 is supposed to be multiplied by this, by this entire log. And that entire log is represented by this. So the 1/3 should be multiplied by all of it. So I can either put in parentheses, and then 1/3 hits both, or I can just say, I'll just stick a 1/3 there. All right. So that's what I needed to do. All right. Well, we still got more to do on this one. Okay. So obviously this log is done. It's just y. There's nothing going on. This one, I've still got multiplication and exponents. So it's not all raised to the same power, but it is one big multiplication problem. So I will use the multiplication addition rule. All right, so we're going to get 1/3 log y. That doesn't change. All right, and it's not going to. Minus 1/3 log z plus 2. It's messy. Z plus 2 to the 8th. And then plus log x to the 5th. All right, cool. But I made another mistake, didn't I? Okay, because right here it says negative 1/3 is supposed to be multiplied by this entire log. And this is what's taking the place of that entire log. So negative 1/3 should get multiplied by all of that. So both parts. So that's something that you just kind of have to be careful of when you're splitting logs up. There's a number out front, coefficient out front. Okay, now there's only one thing left to do. Let's get these exponents finally dealt with. So we'll get 1/3 log y. And then when this 8 comes out, it's multiplied by the 1/3, giving me 8/3. And then log z plus 2, which does not simplify further. And then the 5 comes out, multiplies by the negative 1/3, giving negative 5/3 log x. And that, as far as I can take that, breaking it up. For this last topic, we're just going to do the opposite. So they're going to give us more than one log, and we're supposed to put it all back together. Okay. So I think it stands to reason that it'd be nice to get rid of these parentheses. Okay, so when you've got parentheses, yeah, just get rid of them right off the bat. Let's make your life better. Okay. So minus 15 log base m of x. Okay. All righty. Now, another thing you have to do before you start putting things back together is deal with the coefficients out front. You need to do the exponent rule first, or to get the parentheses done. So bring those guys back in as exponents. So I get the y cubed. I get a w cubed. And I get an x to the 15th. Okay, cool. Now I can put things together. Let's just do it left to right, I guess. And there are shortcuts for this that I'm not going to go into right here. So those two are being added together. So when they're added together, you multiply the arguments. So that's going to give us log base m of y cubed w cubed. Okay, and now I'm subtracting the last two logs, so I do the subtraction division rule, and so let's see, so that'll be log base m of stuff that came first before the minus sign divided by the stuff that came after it. There. It's all neat and tidy, wrapped up with a bow. But don't forget to get those coefficients dealt with. You bring them in before you start combining logarithms. Otherwise, it just throws things off, makes your life extra hard.